Okay, here's our video lesson on the units 3 and 4 diagnostic. So it says if BD is a median to AC, which given statement could lead to a proof that triangle ABD is congruent to triangle CBD by side angle side? All right, so we have to know what a median is. A median connects to a midpoint, and therefore a midpoint splits up that segment into two congruent segments. So medians hook up to midpoints. By the way, altitudes form right angles. People get these mixed up. So just for clarification's sake, okay, if I had a triangle that didn't look isosceles, like it was a scalene triangle, this would be an altitude. So this green segment is an altitude. And if I say this is the midpoint, then the red segment is a median. So two different things. All right, so let's take a look. So I want to prove the two triangles, the two smaller triangles congruent. So I have this side automatically shared. So I want side angle side here. Well, AB congruent to BC would give me side, side, side. That's not going to work. BD bisects angle ABC would give me angles up here, and that would actually give me side, side angle. That wouldn't work at all for congruence, let alone SAS. BD being an altitude produces right angles, and that gives me side angle side. So you have to know what an altitude does. And by the way, I made an error here. This should have been side angle side, but choice C is correct for that one. Okay. Number 2, in quadrilateral ABCD, AD is parallel to BC. Which of the following pairs of angles must be congruent? We have to be very careful when we do this. We're looking for alternate interior angles of the parallel line. That's why I highlighted them. You have the N or the Z shape. The alternate interior angles are in the elbows of the Z. In other words, both segments have to be highlighted. It would be angle DAC to angle ACB, which would be choice C. Be careful. You cannot get the other pair of angles congruent right now because you don't know if AB and DC are parallel. Be very careful with that. Number 3, if C is the midpoint of AD, so now we know this, and angle BCA is congruent to angle ECD, which of the following can be used to prove two triangles congruent by side angle side? Well, this is a pretty easy question. I have my sides, I have my angles. I need the sides connected, the other side connected to the angles. So it would be BC and CE, choice D. Okay. Number 4, which statement is always true? A good idea here is to have an understanding of what the relationships are. So parallelograms, basically their defining characteristic is that you have two pairs of parallel sides. And there's lots of other characteristics, but that's the defining characteristic. Then you have special versions of parallelograms like rectangles, which have right angles and congruent diagonals. Then you have rhombuses, which have all sides congruent. This is a rhombus. Then at the lowest level here, you have squares. So the question here is, what do we have? So I like to use an analogy here. I like to use the analogy about dogs and pugs. Okay? Dogs are more general. Let me actually write this better. Dogs are more general. Okay? Pugs are a breed of dog. They're a type of dog. How about a beagle? That's another type of dog. So what I want to see here is if we can make some analogies. All parallelograms are rectangles. Parallelograms are like dogs. They're the most general. So are all dogs pugs? And the answer is no. All dogs are not pugs. Some dogs are schnauzers, and some dogs are beagles, and some dogs are golden retrievers. So if you use this analogy, it can actually help you. All rhombuses are squares. Again, rhombuses are more general than squares. Rhombuses don't have as much stuff necessarily as squares do. So all dogs are pugs again. That's nonsense. All right, all rectangles are squares. Well, let's see. So rectangles and squares, which one's more general? Rectangles are more general, so all dogs are pugs again. Nope. All squares are rectangles. All pugs are dogs. That I agree with. All pugs are dogs. So squares are most specific. You can remember that. S and S, squares are specific. And parallelograms are general. And you can use the dog and pug analogy to help figure these out. All right, number 5. Which of the following statements are always true about all rhombuses? So here is a rhombus, roughly. All right, and let's see what we know. Diagonals are perpendicular. Well, if you draw an accurate rhombus and you take a look at the diagonals, which I'm drawing in, they happen to be perpendicular. And that's simply because all 4 of these triangles are congruent. And since these 4 angles have to be the same and they add up to 360, they each have to be 90. That's a property that works. Diagonals are congruent. Well, I hope that you see there's a short diagonal and a long diagonal. If you're not sure about that, you could draw a really stretched out rhombus like this. And you'll see you have a short diagonal and a much, 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 much longer one. So that's not correct. The diagonals bisect each other. That is true, and that's true of any parallelogram. So it doesn't just have to be a rhombus. It could be any parallelogram. And so choice 1 and 3 only is correct, choice C. All right, number 6. The pentagon below is formed by 5 rays. What is the value of x? 2 things you have to know about polygons. Polygons are multi-sided figures. The sum of the exterior angles of any polygon is 360. The sum of the interior angles of any polygon is 180 times n minus 2, where n is the number of sides of the polygon. When you can, you try to use the sum of the exterior angles because it's much easier. And in this case, we can. So 30 is exterior, 100 is interior, but I can easily subtract from 180 to get the exterior. Now I have an exterior there. 60 is exterior, 70 is interior, but I can subtract from 180 and get 110. And now I have all 5 exteriors. So I can add them up. 30, 80, 60, 110, and I get, let's see, 3 and 8 is, let's see my math skills here. 3 and 8 is 11, 6 and 11, 6 is 17, 18, and 1 and 1 is 2. So I have 280, and 360 minus 280 is 80. By the way, you could also solve this using the interior angle. So I'm actually going to do that just to get us some practice. I have a 5-sided figure, otherwise known as a pentagon. So I'm going to do 5 in here, and I get 540. That's the sum of the interiors. My interiors would be 150, 100, 120, 70, and I'll call this guy Y. So if I wanted to use the interiors, I could do it. 150 plus 100 plus 120 plus 70, 0. I get, let's see, 5 and 2 is 7, and 7 is 14, and I'm running a 7. Thinking too fast. I have a 4 here, and I get, hold please. Oh, 2, yep, that's good. 7 is 14. And then I have 1, 2, 3, 4. So I have 440. And I know the total is 540. So I subtract from 440, I get 100. And getting 100 for y gives me 80 for x. You can also do it that way as well. Okay. Number 7. In parallelogram ABCD, the measure of angle A was 7x plus 15. The measure of angle B was 20x plus 30. And DE is congruent to DC. I ultimately want to find angle EDC. So I know I have an acute angle and an obtuse angle in a parallelogram. This is the same as 2 parallel lines cut by a transversal. Those angles are supplementary. So I have 7x plus 15 plus 20x plus 30 equals 180. So I have 7x plus 20x is 27x. 15 plus 30 is 45. And I get 180 from there. Subtract 45. I get 27x equals 135. Then I'm dividing by 27. And I get x equals 5. If x is 5, let's see what we have. I have 7 times 5 is 35 plus 15 is 50. 20 times 5 is 100 plus 30 is 130. Just a quick mental check. Those are supplementary. And now I can use a few things here. So one thing that's easy to use is in a parallelogram, the opposite angles are equal. So I know if I have a 50 up in the corner there, I have a 50 here. And this triangle is isosceles. So I can also get the other base angle to be 50. And now I can get the question mark angle pretty easily. 50 plus 50 is 100. And 180 minus 100 is 80. So the measure of angle EDC is 80. By the way, there have to be at least probably 5 or 6 other ways to get angle EDC. So this way that I just did is only one of them. So if you did it differently, it's probably correct if you got it right. All right, number 8, rhombus ABCD is drawn. If AB is 2x minus 1, BC is 3x minus 10, BE is 3y minus 4, and BD, B to D, is 7y minus 12, I want to find AE. So I have a rhombus. So the first thing I know about a rhombus is that the sides of the rhombus are equal. So I can set those two sides equal to each other. So now I'm subtract 2x. Negative 1 equals x minus 10. Add 10 to both sides, and I get x equals 9. So now I know x equals 9. All right, that's important. Now I'd also like to get y. Well, I also know that the diagonals bisect each other for a rhombus. That's true of any parallelogram, actually. So I know that these two pieces are equal. So down here, I also have another 3y minus 4. So I could do 3y minus 4 plus 3y minus 4 is 7y minus 12. And 3y plus 3y is 6y. 4 minus 4 is 8, a negative 8, equals 7y minus 12. I'm subtracting 6y from both sides. I get negative 8 equals y minus 12. Add 12 to both sides. And y is equal to 4. Now, I still have to get, ultimately, I have to get, the goal here is to find AE. All right, so let's see what I have. Well, now I know x. So I know that 2 times 9 is 18, minus 1 is 17. So I know this side is 17. And I know y. So 3 times 4 is 12, minus 4 is 8. Now I want to get AE. I have to know the diagonals of a rhombus are perpendicular. Okay, and so I'm going to have a triangle right here. That's a right triangle. So I can then solve for the guy that I want. I'll call it z. So I have 8 squared plus z squared equals 17 squared. 8 squared is 64 plus z squared equals 289. Subtract 64 from both sides. So I get z squared equals 225. Taking the square root, I get z is 15. All right, one more, and it's a proof. Whew. All right, so we have a parallelogram, and in this case, we're given a parallelogram. We're given a parallelogram, DEBK. So we're given a parallelogram, so we can use all the properties we know about it. I have EC congruent to AK, and I have CJ perpendicular to DB, and LA perpendicular to DB. And we'd like to ultimately prove that CJ is congruent to LA. So I want to try to target some triangles here, and just as a guess, I'm going to try to target this triangle and this triangle for congruency. These two triangles I'm going to target for congruency. So first things first, obviously we have a parallelogram. I have EC congruent to AK and the perpendicular. I'm actually going to start with the perpendicular givens because that gives me some free angles here, or angles pretty quickly in those two triangles. I'm going to try to write as small as I can so I keep the picture on. Okay, so I have to make this statement count, so I'm going to do that by saying angle CJB is congruent to angle DLA. And that's because perpendicular lines form congruent right angles. And that gives me a check toward the 3 that I have. All right, well, there's not a lot else I have, so I'm going to have to squeeze out some juice from that parallelogram. So I know that I have a parallelogram, DEBK. And what am I going to do with that? Well, one thing I can do with that is I can combine it with the second given. What I can say is that from the parallelogram, I know that EB is congruent to DK, and then subtract off EC and AK, and that will give me a pair of sides in the triangle. So that's what I'm going to do. I'm going to have DK is congruent to EB, and that's because opposite sides in a parallelogram are congruent. Now that doesn't count in and of itself. What I'm going to do is I'm going to make a count now. So I'm going to take that given I have. I know that EC and AK are congruent. And what I can do now is subtract. I can say, all right, I'm going to take EB and subtract EC from it. And that's got to be the same as DK subtracted by AK. Whoops, sorry, DK subtracted by AK. And EB minus EC is just CB. And DK minus AK is just DA. So now I know CB and DA are congruent. That counts. And I can say congruent segments subtracted from other congruent segments create new congruent segments. Get into the video. Okay, whoops. Okay, perfect. Now I have a second check. All right, where is the third check coming from? Well, like I said, the parallelogram is juicy, meaning you got a lot of stuff that you can take from it. And so I have these two sides congruent. I have the angle, and if I look, there's another pair of angles I can get basically by saying, oh, look at this. I have two parallel lines cut by a transversal, and that's going to give me congruent alternate interior angles. So we're going to try to prove those angles I just bolded in black congruent. Let me just zoom out here a bit so I get a little more room. Okay. So 7, I'm going to say not only were EB and DEK congruent, but they were also parallel. So EB was parallel to DK. And we know that because a parallelogram, well, opposite sides in a parallelogram are parallel as well. And by the way, if you said that up, up here in the first part of the proof, that's fine as well. If you saw this all coming, you could have done this all at once. And then 8, I have angle EBD congruent to angle BDK because parallel lines form congruent alternate interior angles. And that gives me my third check. So now the proof's pretty easy. I just have to prove the triangle's congruent. So the triangle, I have triangle CJB congruent to triangle ALD. And that's going to be by angle, angle, side. If you're not sure of that, I'll just draw one of the triangles separately. Here's CBJ. I have a right angle. I have this angle and this side. So this would be angle, angle, side congruence. Angle, angle, side here. And 10, well, CJ and LA are just part of those triangles. So this is a pretty easy ending here. I have CJ congruent to LA because incongruent triangles corresponding sides are congruent. And that's it. So hopefully that was good.